Hi folks, my name is Dan Kelly and I work at Dalhousie University.
And my name is Jamie Harbin, and I work also at Dalhousie University and sometimes at Bedford Institute of Oceanography.
And we're both recording this from Halifax in the beautiful province of Nova Scotia in Canada. New Scotland, that's what Nova Scotia is. So this is one video out of probably, there'll be two videos in this series. This is video number 8. It's an introduction to quality control flags. And I'll maybe just quickly talk a little bit about what quality control flags are. So in oceanography, it's very common that data have problems. And I'm not meaning systematic problems that we have in the lab, like maybe a calibration slowly gets off kilter. There's more specific problems. Just a glitch happens to the instrument. It's not a very technical term, but oftentimes you'll have one data point which is very unlike nearby data points and clearly aphysical. And what oceanographers do is they, instead of setting the data to like an NA value or something, they retain it, but they have a little flag saying that they think it's not very trustworthy. And flags are done typically, not always, but typically by numerical codes. And in Argo, they're done by numerical codes. And there's some number of codes, maybe 9 codes or so. And number 1 might mean not checked, number 2 might mean good, number 3 might mean bad, and so forth like that. And so this video that I'm talking to you, I'm showing you here on the screen, something from our GitHub site. And you could see the address here, and I won't bother saying it because you could pause the video. But before we go on, I want to show you a little flowchart of the way that in our package we're envisaging that people would work with this. And this flowchart is just a diagram that's also in yet on working with QC, quality control. The vignette is not really finished and we'll be continuing to work on that for a while, so it's a work in progress. So the first question to ask is, well, what is the quality of the data points? And a good way of finding that out in our package is to use the generic plot command so it'd be plot paren and argo object comma which is equal to QC. And it will make a plot which you'll see in just a minute. The next step to do typically is to try to figure out what tests were performed. And it seems a bit funny to say, but beyond the value, the answer for the test, good or bad, or all those different nuances, there are many different tests, something like 20 tests that are typically performed or could be performed on Argo data. And a given cycle might have all the tests and it might not. And oddly enough, even for a given Argo ID, a given float, some cycles, maybe the first cycle has a certain set of tests done and the third one has a different set of tests done. The way you can look at that is with show QC tests, the function called that. And then another thing to do is just sort of not remove the data. We never remove the data, but we have a function called apply QC, and that will take data that are flagged as being not good and change them into NA. And that's a quick way of allowing to do statistics ignoring those data or plots ignoring those data. So I'm going to stop sharing the screen and we're going to go over to Jamie, who's going to start walking you through the code.
Perfect. Okay. I'm just sharing my RStudio here. So a lot of this is repetition from our other videos. So I'll move a little quickly through some of it. But basically, as we know now in line 4, I'm just loading up our argoFloats package. In line 5, I'm just downloading our built-in index, which is just off of Bahamas. And in line 6, all I'm doing is subsetting for a specific ID number or argoFloat number. And that is because when we do this plot, which equals QC, it just has to be one specific ID number. So that's all I'm doing in line 6. And as you can see, I kept 9 profiles. Line 7, I'm just getting the profiles. And in line 8, I'm just reading them. So again, all of that is explained in our previous videos. Now in line 9 rather, this is when the new plotting occurs. And basically all I'm doing is plotting which equals QC. And as you can see, there's also a parameter argument. So in this case, I'm looking at temperature. But if you're not sure which parameters exist within a given ID, the argoFloats package will actually prompt you. So it'll say, do you want to plot, say, oxygen or different things like that. So I'll just make that happen. And so what you can see, so it's a 2-panel plot. So the first plot, and on both plots, you can see that on the x-axis is the time. And then on the top plot, so this is talking about percent good. So this is based off of flags. So flags 1, 2, 5, and 8 are considered good data. And flags 3, 4, 6, and 7 are bad. And just for completeness, flag 9 is missing. So all this is saying is how much is percent good. So if there's under 50% good, and that's just an arbitrary number that we chose, then the points, which are each a cycle within a given Argo ID, the points are then color-coded with red, meaning bad data, and black for good data. And then the bottom plot here is just showing the temperature mean, and that is incorporating all data, so both good and bad. So now what we do is to take it a step further. So we see, okay, how much is considered good, how much is considered bad, but now we want to know why that is the case and which tests were actually performed. So in line 12, all I'm doing is looking at the cycle numbers of this particular ID. So in this video, we're going to focus on the first cycle here, where it is considered bad. And as you can see here, that is cycle 124. So all I'm doing in line 13 is just subsetting for that particular cycle. And then in 14, I'm just getting the profiles, and in 15, I'm reading the profiles. So now in line 16, what ShowQC test does is it looks at the hexadecimal within the history QC test of the netcdf files, and it corresponds with the history action. So either QC test failed or QC test performed. And what I'll do here, so this is the output for this particular cycle. So again, this first cycle here. So you can see that it failed test 14, which is the density inversion test. And this is also the list of which tests were performed. Now, of course, as Dan mentioned, there are many tests that can be performed. So if you want a little bit more information on, well, what do those tests mean? That's when you can just run what we call style equal old. Oh, I'll just put in my S there. And then as you can see, it actually tells you which tests were skipped, which were passed, etc., as well as the name of each test. So Dan, this is where I'll pass it over to you, although I know that we will continue to share my screen.
Good. Right. So let's see. So we're okay. This function that we have called apply QC, what that does, the object in this case called Argos, is containing within it a bunch of objects defined by a function in the OCE package, and those are of class Argo, not plural Argo. What it does, apply QC, what it does, it looks for each of these things and runs something called handle flags in OCE. And what that does is it finds any data that are not in the good category that Jamie just said, and it switches them to be NA values, or not appropriate or missing, or whatever you want to call that. So if you could make that line happen, Jamie. And maybe the next line too. So this is just setting up now for a 2-column plot. Maybe make the next line happen. So this first one, first plot, is showing you a test diagram for Argos before we cleaned the data. And just a glance, any oceanographer would look at this and say, these are clearly wrong. Okay, there's some nuances here. The thing called absolute salinity is a sort of newish, 10-year-old now, it's not really very new, way of defining salinity, but that's the saltiness in the water. It's typically in the range of something near 34, 35, in that kind of a range. So those high salinities are just clearly not correct. There's nowhere in the ocean that has salinities like that. And especially not for one particular float. Each of these cycles is 10 days separate for the other. There's no way from one time to another that the salinity doubles. Like that would mean boiling away half the water, which it's just impossible to imagine. And the other is the temperatures. It's called conservative temperature. You could just read that as a temperature if you want for now. And the temperatures are 60 degrees. Well, that is still pretty hot coffee or tea. So these are just clearly erroneous values. The black ones here are ones that have quality control flags saying it's good, and red ones are quality control flags saying that it's bad. Just one more thing that I'll say, and that is that the curved gray line there is isopycnal. That's a line of constant density. And this plotting algorithm won't even show you isopycnals in a region outside what are considered the known region, I'll say the known region for seawater. In other words, the isopycnal formula is a regression calculation based on oceanographic data, and it's considered risky to extrapolate beyond a certain region. That's why those contours cut off. So that's a bunch of reasons why any oceanographer would look at this and see those data are terrible. Can you make the next one happen, Jamie?
Sure.
So now it's the same data, but what we're showing, again, clean does apply QC flags, so it's set to NA, any values that failed tests. And this diagram looks to me much more reasonable. First off, the salinity range is what I would expect. The temperature range is what I would expect. The bottom of the diagram, the cold water, is down near the deep water in the ocean. In the ocean, the deep water tends to be cold everywhere. I can tell immediately that this Argo is in a warm region of the ocean, the Bahamas, is where this happens to be, because of those warm surface temperatures. If you looked at an Argo off Nova Scotia, the highest temperature wouldn't be 30 degrees. Now, Jamie, could I get you to move your mouse over in the conservative temperature on the right-hand side, the funny one on just the isolated guy? Okay, good. So visually, I would look at this and say, that is also clearly wrong. It's not that the temperature is crazy or that the salinity is crazy, but the combination of them is very unlike the rest of the data. And the way an Argo float works is it's ascending in the water column, and it's making measurements every once in a while, and it's producing data, I'll say every meter or something like that. And so what this means is that during one of those ascents, the temperature, let's say the salinity, went from wherever it was, I'll just guess 36 point something, and it jumped down by a whole unit. Highly unlikely to happen, and then immediately jump back. So one of the points in the cloud is the point just below it, 1 meter deeper, and another point in the cloud is the point 1 meter higher. That means that the temperature and salinity, no matter how you cut it, each jumped by a huge amount compared to the other data. This, I think, should have been caught by a QC, by the QC analysis, but it clearly wasn't. Maybe, Jamie, you can move your mouse over to the ones that are on the right, the outliers on the right there. And again, these ones, I think, I'm surprised that they got through the QC analysis. Now, it's a bit like a movie with a sequel. So I have a sequel in mind, and we've actually been looking in more detail here, and I don't want to give away the story. But there are ways in which you can look in more detail to find out, well, how could those have passed the flags? Maybe they passed the checks, and that indicates that the checks are being done incorrectly in this instance, or just maybe they're designed incorrectly. Or maybe some of these are individual cycles that had different tests applied than other ones did. So that's the kind of mystery that we'll see if we can solve in the next video. But for now, I'll just say our procedure has illustrated the data which are suspect. If comparing these two panels shows that we can do a pretty good job of cleaning up the data. I feel if I were working on this, for an individual paper, or certainly a student working on it, any student's thesis supervisor would say, those data are crazy and you've got to clean them up somehow. So that's what we'll see if we can get into when we cause trouble with video 9. Did you have anything else you want to say, Jamie?
No, I think that was everything we wanted to cover.
Well, good. Well, thanks, folks, for listening or viewing this video, and stay tuned for an update on the exciting world of flags. So long.
See you later.